Hi, my name is Basir. In this video series, I will be teaching you Chapter 7 Coordinate Geometry from Cbse Class 10 syllabus. In your previous grade, you must have already learned how to plot a point on a graph paper. The plane of the graph paper containing the horizontal line, which we call as the x-axis, and the vertical line, which we call as the y-axis, is called a Cartesian plane. Now, a plane is simply a two-dimensional flat surface which can extend infinitely in both the directions. Coordinate geometry is a branch of geometry where the position of the points on the plane is defined with the help of an ordered pair of numbers, also known as coordinates. The x-axis and the y-axis are known as the coordinate axis. The x-axis and the y-axis, we call them as the coordinate axis. And the x-axis and the y-axis, they meet at a point which we call as the origin. And the coordinates of the origin are obviously 0, 0, isn't it? Because at the origin, the x coordinate is 0 and the y coordinate is also 0. To plot a point 4, 5 on the graph paper, we start from the origin 0, 0. Let us say I want to plot a point 4, 5 on the graph paper. Then how are we going to plot this point on the graph paper? We start from the origin and then we move 4 units along the x-axis. The first coordinate that you see here, that is your x coordinate, and then the second coordinate that you see here, that is your y coordinate. The x coordinate is known as abscissa. So here abscissa is 4. The x coordinate that you see here, that is known as abscissa, and the y coordinate 5, the y coordinate is known as ordinate. Let us see how to plot the point 4, 5 on the graph paper. We first start from the origin. We need to go 4 units along the x-axis. 1, 2, 3, 4. 4 units along the x-axis. And then we need to move 5 units along the y-axis. So 1, 2, 3, 4, 5. 5 units along the y-axis. I have reached here. Now this is the point 4, 5. That is the point 4, 5. It reads, when you go to the x-axis, it reads 4. So you can see here, when you go to the x-axis, it reads 4. And then when you go to the y-axis, it reads 5 on the y-axis. It reads 5 on the y-axis. So that is our point 4, 5. The x coordinate gives us the distance of this point from the y-axis. The x coordinate is 4 here, isn't it? So the x coordinate gives us the distance of this point from the y-axis. You can check it for yourself. 1, 2, 3, 4. Yes, so we see that the distance of this point from the y-axis, the vertical axis, is 4 units, and the y coordinate gives us the distance of this point from the horizontal axis, which is the x-axis. We see that the y coordinate is 5, so the distance of this point from the x-axis is 5 units. You can check it for yourself. 1, 2, 3, 4, 5. So the distance of this point from the y-axis is 4 and the distance of this point from the x-axis is 5. A point on the x-axis is of the form x, 0. A point on the x-axis is of the form x, 0, because obviously on the x-axis the y coordinate will be 0. If I want to read what this point is, obviously the x on the x-axis, it says 2, and then if I go towards the y-axis, it says 0. So on the x-axis, remember, any point on the x-axis will be of the form x, 0, because on the x-axis the y coordinate is 0. Let me pick up one more point here. Let us say I choose to pick up this point. What are the coordinates of this point? On the x-axis it says 7, so let me write 7 here, and then if I move towards the y-axis, it actually reaches 0 of the y-axis, right? So the y coordinate here is 0. The first coordinate is your x coordinate always, and then the second coordinate is your y coordinate always. So you can see for yourself, any point on the x-axis is of the form x, 0, which means on the x-axis, the y coordinate is 0. Likewise, any point on the y-axis will be of the form 0, y. You can see for yourself, if I choose 2 points here, let me choose this point here, and then let me choose this point here. What are the coordinates of this point? This point is 0, 2, because the x coordinate is 0 and then the y coordinate is 2. And what would be this point? The x coordinate is 0 and the y coordinate is 6. So you can see for yourself, any point on the y-axis is of the form 0, y. So on the y-axis, the x coordinate is 0. Now let us say I want to find out the distance between these 2 points. I want to find out the distance between the points 2, 0 and 7, 0. How can I find the distance between 2 points that are lying on the x-axis? Let us say this point, I am denoting it by x1, y1, and then this point, let us say this point is x2, y2. The distance between 2 points lying on the x-axis is always equal to x2 minus x1. What is x2 here? 7 minus, what is x1 here? 2. 7 minus 2 is how much? 5. So you can check for yourself. The distance between these 2 points would be 5. Let's check it for ourselves. From here to here 1, and then from here to here 1 more, which means we got 2 now. From here to here 1 more, so 3. From here to here 1 more, so 4. From here to here 1 more, so 5. 1, 2, 3, 4, 5. The distance between these 2 points is 5 units. So understand, the distance between 2 points on the x-axis is always given by x2 minus x1. x2 minus x1. If you want, you can actually check it by this also. This point is 7 units away from the y-axis, and then this point is 2 units away from the y-axis. So if from the total 7, if you remove 2, you'll be left with 5. So the distance between this point and this point will anyways be 5 units. And what would be the distance between 2 points that are plotted on the y-axis? What would be the distance between the points plotted on the y-axis? Let us say this point is x1, y1, and this is x2, y2, which means x1 is 0, y1 is 6, x2 is 0, y2 is 6. The distance between 2 points lying on the y-axis is always y2 minus y1. What is y2 here? y2 is 2 here, and then what is y1 here? y1 is 6 here. 2 minus 6, that gives us minus 4, but we always take the absolute value because obviously the distance cannot be negative. So the absolute value, you will get it as 4. So you can see for yourself the distance between the point 0, 2 and the point 0, 6, which are lying on the y-axis, is 4 units. You can check it by yourself. 1, 2, 3, 4, isn't it? So the distance between any 2 points lying on the y-axis is y2 minus y1, and distance between any 2 points lying on the x-axis is x2 minus x1. If the line segment joining 2 points is parallel to the x-axis, then the distance between the 2 points is again x2 minus x1. Let us say I have 2 points here, 2, 4 and 8, 4, and I want to find out the distance between these 2 points. What would be the distance between these 2 points? Since the line segment joining these 2 points is parallel to the x-axis, the distance between these 2 points is again going to be x2 minus x1 itself. Let us say this point is x1, y1, which means x1 is 2, the value of y1 is 4. Let us say this point is x2, y2, the value of x2 is 8, the value of y2 is 4. Let us substitute the values here. x2 is 8 and then x1 is 2. So 8 minus 2, that gives us 6. So if there is a line segment joining 2 points, and if the line segment joining the 2 points is parallel to the x-axis, then the distance between the 2 points is going to be x2 minus x1 once again. If you want to check it from the graph, you can very well check it from the graph as well. If I move down towards the x-axis, it says 8 here. If I move down towards the x-axis, it says 2 here. So you can see for yourself, from here to here the distance is 8, from here to here the distance is 2. So from the total 8, if I subtract 2, I will be left with 6. So this distance would be 6. If this distance is 6, obviously this distance also has to be 6. Looks like a rectangle, the opposite sides are equal, so if this is 6, this is also 6. So remember, if there is a line segment joining 2 points, and if that line segment is parallel to the x-axis, then the distance between the 2 points is going to be x2 minus x1. Similarly, if we have a line segment joining 2 points, and if this line segment is parallel to the y-axis, if this line segment is parallel to the y-axis, then the distance between the 2 points is going to be y2 minus y1. Let us say this is our x1 y1 and this is our x2 y2. Then what is y2 here? Y2 is 7, and then what is y1? Y1 is 12. 7 minus 12 is minus 4. Since the distance cannot be negative, so we will take an absolute value here, which is 4. The distance between these 2 points is 4 units. Sorry, 12 minus 7, that gives us 5, right? So the distance between these 2 points is 5 units. You can read for yourself. You can check it for yourself. 1, 2, 3, 4, 5. The distance between these 2 points is 5 units. If you want to check it from the graph, you can check it from the graph. Also, if I move towards the y-axis, it says 12 here. And from this point, if I move towards the y-axis, it says 7 here. So the distance from the origin to here is 12, and the distance from the origin to here is 7. So from total 12, if I remove 7, I'll be left with 5. So this is 5 units. If this is 5 units, obviously this also would be 5 units, because this thing right here, it looks like a rectangle, isn't it? It looks like a rectangle, so the opposite sides, they have to be equal. So if this is 5 units, this is also 5 units, isn't it? So what have we learned here? We learned that if I have 2 points on the x-axis, then the distance between 2 such points would be x2 minus x1. And if I have 2 points in such a manner that the line segment joining the 2 points is parallel to the x-axis, then also the distance between the 2 points is x2 minus x1. If I have 2 points lying on the y-axis, then the distance between the 2 points is y2 minus y1. If I have a line segment joining 2 points and the line segment joining the 2 points is parallel to the y-axis, then also the distance is equal to y2 minus y1. So we learned how to find out the distance between 2 points if the line segment joining them is parallel to the x-axis, and we also saw how to find the distance between the 2 points if the line segment joining them is parallel to the y-axis. But what if the line segment joining the 2 points is neither parallel to the x-axis nor parallel to the y-axis? For an example, I have a line segment here which is joining the 2 points x1 y1 and x2 y2, and then this line segment is not parallel to the x-axis. It is also not parallel to the y-axis. Then how am I going to find out the distance between 2 such points? I want to find out the distance between these 2 points. How are we going to find the distance between these 2 points? Now, if I look at this point, we denoted this point by x1 y1. The coordinates of this point are this point are x1 y1. So if I go to the x-axis, it should read x1. If I go towards the y-axis, it should read y1. The coordinates of this point are x2 y2. So if I move towards the x-axis, it should read x2, and if I move towards the y-axis, it should read y2. And what would be the distance between from here to here? The distance from here to here would be x2 minus x1. Why? Because obviously the distance from here to here is x2 and the distance from here to here is x1. So from the complete x2 distance, if I remove x1 distance, I'll be left with this thing, x2 minus x1. In the same manner, the distance from here to here is y2. The distance from here to here is y1. So from the total distance of y2, if I subtract y1, I'll be left with this distance, y2 minus y1, isn't it? Now, I am interested in finding the distance between these 2 points. The 2 points that you see here, the line segment joining these 2 points is not parallel to the x-axis, and this line segment is not parallel to the y-axis also. So what are we going to do to find the distance between 2 such points? What we can perhaps do is we can draw a right angled triangle here like this. Let us draw a right angled triangle like this. What do you suppose this distance should be? What do you suppose this distance should be? Since this distance is x2 minus x1, this distance also should be x2 minus x1. Don't you think so? And then since this distance is y2 minus y1, this distance from here to here, it also should be y2 minus y1, isn't it? Now since this is a right angled triangle, I can make use of the Pythagoras theorem. Let us say this is my point A, this is my point B, and then let us say this point we denote it by P. Let us make use of Pythagoras theorem here. Pythagoras theorem says that the square of the hypotenuse is equal to sum of squares of the other two sides. Now what is the hypotenuse in the right angle triangle APB? The hypotenuse is AB. How do I know? See, the hypotenuse is always the longest side in a right angle triangle, and the hypotenuse is always opposite to the right angle. Here the right angle is at P, and opposite to angle P I see the line I see the side AB. So I see the side AB, so obviously AB is the hypotenuse. So square of the hypotenuse is going to be sum of squares of the other two sides. The other two sides are AP and BP. AP and BP. So as per the Pythagoras theorem, AB square should be equal to AP square plus BP square. Now I want to find out AB, which means I want to find out the distance between the point A and the point B. What is AP here? AP is x2 minus x1. So in place of AP, let me write x2 minus x1 whole square as it is. And what is BP? BP, the distance between the points B and P, BP is y2 minus y1. So in place of BP, let me write y2 minus y1 square as it is. Now if I remove the square from the left hand side, I have to keep a square root on the right hand side, isn't it? So AB is the distance between the points A and B, and we see that the distance between the 2 points can be calculated by using the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. So remember, distance between any 2 points can be found out by using this formula. Let me write the formula once again for you. So the distance between the points x1, y1 and x2, y2 can be found out by using the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let me find out just take 2 points and let me try to find out the distance between 2 such points. Let us say I want to find out the distance between point A and point B. The coordinates of point A are 2, 3 and the coordinates of point B are 4, 1. And let me find out the distance between these 2 points by using the distance formula. Now I'm going to denote this by x1, y1 and I'm going to denote this by x2, y2. So in the distance formula, in place of x2, I need to write 4. In place of x1, I need to write 2. In place of y2, I need to write 1. In place of y1, I need to write 3. So let's do that. In place of x2, I'm writing 4 here. In place of x1, I am writing 2 here. The square in the formula, I need to write it as it is. In place of y2, I need to write 1 here. In place of y1, I need to write 3 here. I'm just doing a simple substitution here. Now what happens? 4 minus 2 is 2. The square, it is as it is. 1 minus 3 is minus 2. The square, I need to keep it as it is. 2 square is 4. Minus, if you square it, it becomes plus, isn't it? Because the power here is 2, which is an even number. It is an even number. The power is an even number. So minus becomes plus. 2 square is nothing but 4 itself. 4 plus 4 is 8. Now you can keep it this way, or perhaps the best thing to do is you can take prime factorization of 8. 2 into 4 is 8, 2 into 2 is 4, 2 into 1 is 2. So in place of 8, you can write 2 into 2 into 2. 2 into 2 into 2. And out of 2 same numbers, you can take one number outside the square root, and in the root only just this 2 is remaining in the root. So the distance between these 2 points is 2 root 2. Instead of using the distance formula as square root of x2 minus x1 whole square plus y2 minus y1 whole square, you can very well write it like this as well. You can very well write it, instead of writing square root of x2 minus x1 whole square plus y2 minus y1 whole square, instead of writing it like this, instead of writing x2 minus x1 whole square plus y2 minus y1 whole square, you can actually write it like this also. You can swap their places. You can write x1 here and then x2 here. You can write y1 here and then y2 here. You can swap their places and you can write like this also. It doesn't make any difference. Why? Because after subtracting x1 and x2, when you square them, you end up getting the same thing. Now, if you are not able to follow me, then I would suggest you to find the distance between these 2 points using this formula, and then you will realize for yourself why the distance would remain the same even if you use this formula. Okay, now I'm interested in finding the distance of a point x comma y from the origin. That's the origin, and I have just drawn the positive x-axis and the positive y-axis. Okay, now that's our origin where the x-axis and the y-axis meet. I want to find out the distance of the point x comma y from the origin. Let us say I denote this point by the letter A. I want to find out the distance OA. I want to find out the distance OA, meaning I want to find out the distance between the point O and the point A. What am I going to do? Now, the coordinates of this point are x comma y. So if you move towards the x-axis, it should read x, and then if you read towards the y-axis, it should say y, isn't it? Now, what is this distance from here to here? This distance from here to here is x, because it says x here, and then this distance from here to here, it is y. Since this distance is y, this distance also has to be y. Now, if I make this a right angle triangle, I can apply the Pythagoras theorem here once again, isn't it? Let us say this is the point P here, and then let us say this point is some O. I can make use of the Pythagoras theorem here to find out OA, which is the distance between the point O and the point A, the distance from the origin to a point on the graph. So let us use the Pythagoras theorem. The Pythagoras theorem says that the square of the hypotenuse is equal to sum of squares of the other two sides. Here the hypotenuse is OA, so the square of the hypotenuse should be equal to sum of squares of the other two sides. What are the other two sides? OP and AP. OP and then AP, isn't it? So OA square is going to be, what is OP? OP is x. So let me write x in place of OP, the square I'm writing it as it is, and AP, what is AP? AP is y, so let me write y in place of AP, the square, as it is. So OA is going to be, if I remove the square from the left hand side, I'll have to write a square root on the right hand side. So you can see for yourself the distance from the origin to a point A is square root of x square plus y square. So remember, the distance of a point from the origin can always be found out by using the formula square root of x square plus y square. We are now ready to solve the questions from exercise 1, as we exclusively make use of just the distance formula to solve all the questions from the first exercise. This is the very first question from exercise 7.1. It says, find the distance between the following pairs of points. So we have a pair of points given to us, and we have to find the distance between these 2 points. Let me first write the pair of points that is given to us, 2, 3, and then the next one is 4, 1. So I need to find the distance between the points 2, 3 and 4, 1. The first thing that I would do is, let me say that this is x1, y1, and let us say that this is x2, y2. So x1 value is 2, and then y1 is 3, x2 is 4, y2 is 1. And I need to find the distance between these 2 points. How do we find out the distance? for finding the distance between 2 points, we can use the distance formula. A while ago we learned the distance formula, right? It is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let us substitute the values here. In place of x2, I need to substitute 4, keep the minus sign. In place of x1, I need to substitute 2 here, plus in place of y2, I need to substitute 1. In place of y1, I need to substitute 3. So what happens now? 4 minus 2 is nothing but 2 itself, and then 1 minus 3 is minus 2. The square, I'm writing it as it is. Now what happens? Square root of 2 square is 4, minus when you square it, it becomes plus, isn't it? 2 square is again 4. Now 4 plus 4 is 8. We can take prime factorization of 8. 2 into 4 is 8, 2 into 2 is 4, 2 into 1 is 2. So 8 can be written as 2 into 2 into 2. Out of two same numbers, you can take out one number outside the square root, and inside the square root this 2 is remaining. So the distance between these 2 points is 2 root 2. Let us also find out the distance between these two pairs, minus 5 comma 7 and minus 1 comma 3. I need to find out the distance between these 2 points. Again, let us say this is x1 y1 and let us say this is x2 y2. Let us write the distance formula. What is the distance formula? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. Let us substitute the values here. In place of x2, I need to substitute minus 1. Keep the minus sign from the formula. In place of x1, I need to substitute minus 5. But then this minus sign and this minus sign, they are very close to each other. So let me separate them by using a bracket here. In place of y2, I need to write 3, and then in place of y1, I need to write 7. Now what happens? Square root of minus 1, minus into minus, that is plus. 3 minus 7 is minus 4. So what do I end up getting? 5 minus 1, which is 4, the square as it is. Minus 4 square, let me write it as it is for now, and let me square them now. 4 square is 4 into 4, which is 16, minus, if you square it, it becomes plus, isn't it? 4 square is 16 once again. 16 plus 16 is 32. Now what you can do, you need to do prime factorization of 32. Let us find prime factorization of 32. 2 into 16 is 32, 2 into 8 is 16, 2 into 4 is 8, 2 into 2 is 4, 2 into 1 is 2. So in place of 32, I can write 2 into 2 into 2 into 2 into 2, 2 multiplied 5 times. 1, 2, 3, 4, 5 times. 1, 2, 3, 4, 5. 2 multiplied 5 times. Now what can I do? Out of two same numbers, I need to take one number outside the square root, and out of two same numbers again, take one number outside the square root. So out of these two same numbers, I took 2 outside the square root. Out of these two same numbers, I took one more 2 out of the square root, and inside the square root I just have this 2 remaining. Now what happens? 2 into 2 is 4. So 4 root 2 is the distance between the 2 points. Let us also find out the distance between these two pairs of points. The third bit, I need to find the distance between a comma b and minus a comma minus b. Let us say this is x1 y1, let us say this is x2 y2, and what is the distance formula? The distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. And I told you that instead of writing x2 minus x1, you can write it as x1 minus x2 also. You can write it as y1 minus y2 also. It doesn't make a difference, because after you subtract, you are anyway squaring it. So it doesn't really make any difference. Now you can substitute this directly here in this formula, or you can pretty much, instead of writing square root of x2 minus x1 whole square plus y2 minus y1 whole square, you can instead use x1 minus x2 whole square. I told you they can interchange the places. and then instead of writing y2 minus y1, you can write y1 minus y2 as well. I'm going to substitute here. It's your personal choice. You can substitute here as well. You end up getting the same answer. Do not worry. Now in place of x1, I need to write a, keep the minus sign from the formula. In place of x2, I need to write minus a, and then the square from the formula I need to write as it is. But then since these two negative signs are very close to each other, let me separate them by using a bracket. Now in place of y1, I need to, okay, this is x1 y1. In place of y1, I need to substitute b, keep the minus sign. In place of y2, I need to substitute minus b, and then square from the formula, write it as it is. Now let me separate them by using a bracket here. Now what happens? Square root of a minus into minus is plus a whole square, and then b minus into minus is plus b whole square. Now a plus a is nothing but 2a whole square, plus b plus b is nothing but 2b whole square. Square root of, square goes to 2 also, square goes to a also. So when square goes to 2, 2 square becomes 4, isn't it? 4a square plus 2 square is 4b square, 4b square. Now you can take 4 common from the two terms, because I have 4 in the first term and then I have 4 in the second term as well. So let us take 4 common. If I remove 4 from here, I'll be left with a square, and if I remove 4 from here, I'll be left with b square. Now square root of 4 is nothing but 2, so 2 goes outside the square root. You can consider it this way also. Root goes to 4 also, root goes to a square plus b square also. Square root of 4 is 2. So 2 under root a square plus b square is the distance between these 2 points. Let us now move on to the second question. This is the second question. It says, find the distance between the points 0, 0 and 36, 15. Can you now find the distance between the two towns A and B discussed in section 7.2? Okay, so these are the 2 points that are given to us, 0, 0 and then 36, 15. So those are the 2 points that are given to us, and we are supposed to find the distance between these 2 points. As usual, you can take this as x1, y1 and take this as x2, y2 and find the distance between the 2 points by using the distance formula. But then, since the first point is an origin, I understand the x-axis and the y-axis, the point where the x-axis and the y-axis meet, we call it as the origin, and the coordinates of the origin are always 0, 0, right? The coordinates of the origin are 0, 0, and you know that to find the distance of a point from the origin, you can perhaps use a simple formula, a rather simple formula, instead of using the usual distance formula that we were using in question number 1. You can just use square root of x square plus y square, where x is 36 square as it is, y is 15 square as it is. So you can pretty much just use this formula, because you are finding the distance of the point 36, 15 from the origin. To find out the distance of a point from the origin, you can perhaps use a smaller formula, square root of x square plus y square. X coordinate is 36, the y coordinate is 15. So in place of x, let us write 36, in place of y, let us write 15. Now, how much is 36 square? 36 square, let us find out. 36 into 36. 6 into 6 is 36. 6 into 3 is 18. 18 plus 3 is 21. 3 into 6 is 18. 3 into 3 is 9. 9 plus 1, that gives us 10. So I see that 36 square is 1296. And how much is 15 square? 15 square is 15 into 15, which is 225. Let us add them up. Now 1296 plus 225, if I add them, I end up getting 1521. Let us now find out the square root of 1521. I hope you know how to find out the square root of 1521. I mean, there are 2 ways to find out the square root of this number. You can find the square root of a number by using prime factorization, or you can find the square root of a number by the division method. I'm going to use the division method that we already learned in grade 9. Let us keep a bar on these 2 numbers. and let us keep a bar on these two numbers. Now what happens? 3 into 3, that gives us 9. 15 minus 9 is 6. Add 3 here. 3 plus 3 is 6. Bring down the next number. And then I write 9 here and then multiply by 9. What happens? 9 into 9 is 81. 9 into 6 is 54. 54 plus 8 is 62, isn't it? So 69 into 9 is 621. 621 minus 621 is 0. The square root of 1521 is 39. So that's the square root. That is the distance between these 2 points. So the distance between the points 0, 0 and 36, 15 is 39. If you want to understand how to find out the square root of a number using the division method, I believe I already created a video explaining how to find out the square root of a number by using the division method. You can watch that video. Okay, now let us find out the distance between the towns A and B that were discussed in section 7.2. This is the figure that was given in section 7.2. The town A is here and the town B is here. We need to find out the distance between the two towns. You can see for yourself, town A is actually at the origin because town A is at a point where the x-axis and the y-axis are meeting. So the town A is at the origin 0, 0. And what are the coordinates of town B? Can we get the coordinates of town B? Yes, we can. The coordinates of town B are 36, 15. How? The x-coordinate gives you the distance of the point B from the y-axis. The distance of B from the y-axis is 36. And the y-coordinate gives us the distance of this point from the x-axis. And you can see the distance of this point from the x-axis. This is the x-axis. From the x-axis, the distance is 15. So this point, town B, has the coordinates 36, 15, and we now need to find out again the distance between the point 0, 0. Town A coordinates are 0, 0, and then the town B coordinates are 36, 15. But we already found it out. So using this method, we can find out the distance between the town A and town B. The distance between the town A and town B would be 39 units. Let's move on to the third question. Now the third question says, determine if the points 1, 5, 2, 3 and -2, -11 are collinear. What do you mean by collinear? If the points lie on the same line, you call those points as collinear. Points lying on the same line are known as collinear. So we need to check if these 3 points lie on the same line. Now, if the 3 points are lying on the same line, let us say this is point A, let us say this is point B, and let us say this is point C. If the 3 points, point A and then point B and then point C, if all the 3 of them lie on the same line, then you can see for yourself AC should be equal to AB plus BC. If you add up AB and then BC, obviously you end up getting complete AC, isn't it? So AC should be equal to AB plus BC. What is AC here? AC is nothing but the distance between the point A and point C. AB is the distance between the points A and B. BC is the distance between the points B and C. So we'll find out the distance AB, we'll find out the distance BC, we'll find out the distance AC, and if AC is equal to AB plus BC, we will say that the 3 points lie on the same line. So they are collinear. If this condition does not meet, then the points will not be collinear. So let us first find out AB, and then we'll find out BC, and then we'll find out AC. Let me find out AB. Let me first write the coordinates of A and coordinates of B. Now A is 1, 5 and then B is 2, 3. Let us say this is x1, y1 and then this is x2, y2. Let us use the distance formula to find out the distance between point A and point B. Now x2 minus x1 whole square plus y2 minus y1 whole square. In place of x2 I need to write 2 and then in place of x1 I need to write 1, in place of y2 I need to write 3, in place of y1 I need to write 5. So AB is going to be square root of 2 minus 1 is 1, so 1 square plus 3 minus 5 is minus 2, isn't it? And then it has a square here. 1 square is 1, minus if you square it, it becomes plus. 2 square is 2 into 2, which is 4. So I am getting the distance between A and B points as root 5. 1 plus 4 is 5. So the distance between the point A and point B is root 5. Let us also find the distance between the point B and point C. Let me first write the point B and point C. Point B is given as 2, 3, and then point C is given as minus 2, minus 11. Let us say this is x1, y1 and this is x2, y2. Let us find out the distance. Now every time I am not going to use the distance formula, I'm not going to write the distance formula and do it. I will pretty much do it a little straightforward from here. What do I need to do? I just need to subtract the x coordinates and then I need to subtract the y coordinates, right? You are subtracting the x coordinates and squaring them, plus you are subtracting the y coordinates and then squaring them. So that's what I'm going to do it directly here from now onwards. However, I would suggest you to write the distance formula first and then do the substitution the way I did when finding the distance between point A and point B. Now this is 2 here, minus 2, that becomes plus 2 whole square. This is 3 here, minus of minus 11, that gives us plus 11. So this is what I did. Instead of using x2 minus x1, I used x1 minus x2. We can do that, right? 2 minus of minus 2, minus of minus, that becomes plus. 3 minus of minus 11, minus of minus, that becomes plus. So what do I end up getting now? 2 plus 2 is 4, the square as it is. 11 plus 3 is 14, the square as it is. 4 square is 16, 14 square is 196, 196 plus 16 is how much? 6 plus 6 is 12, 9 plus 1 is 10, 10 plus 1 is 12, sorry, 9 plus 1 is 10, 10 plus 1 is 11, 1 plus 1 is 2, so I end up getting this as square root of 212. 212, you can take prime factorization of 212 and then simplify this a little bit here. 212, let me take prime factorization of 212. 2 into 1 is 2, 2 into 6 is 12, 2 into 5 is 10, 2 into 3 is 6. 53 is a prime number, so obviously 53 into 1 is 53. So BC is square root of 2 into 2 into 53. 2 into 2 into 53. Out of these two same numbers, I can take one number outside the square root, and inside the square root I have this 53 remaining. So the distance between point B and point C is 2 root 53. The distance between point A and point B is root 5, and the distance between point B and point C is 2 root 53. Now let me also find out the distance between point A and point C. What is A here and what is C here? A is 1 comma 5, A is 1 comma 5, and then C is minus 2 comma minus 11. Let me find out the distance between point A and point C. AC is going to be square root of, I'm subtracting the x coordinates and then squaring them, and then I'm subtracting the y coordinates and then squaring them. 1 plus 2 is 3, 11 plus 5, that gives us 16, square as it is. 3 square is 9, 16 square is 256, 256 plus 9 is 355, isn't it? Sorry, 256 plus 10, that gives us 266, so this has to be 265. 256 plus 9, that gives us 265. Let us take prime factorization of 265. 5 into 5 is 25, 1 goes here. 5 into 3 is 15, 53 into 1 is 53. So I see that 5 and 53, they are appearing only once, so I cannot take any number outside the square root. So AC is going to be square root of 265 itself. I cannot simplify it any further. 5 into 5 is 25. 1 goes here. 5 into 3 is 15. Yeah. So AC is the distance between the point A and the point C is square root of 265. Square root of 265. So you can see for yourself, AB plus BC is not equal to AC, because root 5 plus 2 root 53 is not equal to 2 root 65. If you add root 5 and 2 root 53, you are not going to get root 265. So AB plus BC is not equal to AC. Hence, the 3 points are not collinear. Therefore, A, which is 1, 5, B, which is 2, 3, and C, which is -2, -11 are not collinear. They are not collinear. Let's move on to question number 4. Okay, now the question number 4 says, check whether 5, -2, 6, 4, and 7, -2 are the vertices of an isosceles triangle. Now, what is an isosceles triangle? An isosceles triangle is a triangle in which 2 of the sides are equal, right? If 2 of the sides are equal in a triangle, you call such a triangle as an isosceles triangle. Let us say this is point A, let us say this is point B, and let us say this is point C. Let me write the point A here, which is 5, -2, point B is 6, 4, point C is 7, -2. So what am I really going to do? I will find out AB, which is the distance between point A and point B. So I'll find out the side AB, and then let us find out the side BC. Let us find out the side AC. You can find the distance between point A and point B by using the distance formula, right? Again, using the distance formula, you can find out BC. Using the distance formula, you can find out the side AC as well. If 2 of the sides are equal, then we'll say that these points form an isosceles triangle. If not, we'll say that the points do not form an isosceles triangle. So let me first find out the side AB. What is A given as? A is 5, -2, and then B is 6, 4. Let us say this is x1, y1, and let us say this is x2, y2. Let me write the distance formula. Distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. In place of x2, I'm going to write 6. In place of x1, I'm going to write 5. In place of y2, I'm going to write 4. In place of y1, I'm going to write -2. Now what happens? Square root of 6 minus 5 is 1, and then 4 minus into minus, that gives me plus. So what happens now? Square root of 1 square is 1 itself. 4 plus 2 is 6 square. I'm writing it as it is. So this becomes 6 square, which is 36. 36 plus 1 is 37. So root 37. So the side AB is root 37. Let me also find out the side BC. Let me first write the coordinates of B and C. So this is x1, y1, and this is x2, y2. Let us find out the distance between the points B and C. So the distance between the points B and C will give you the side BC, isn't it? Now, what is the formula again? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, what is x2? In place of x2, let me write 7. In place of x1, I'm going to write 6. In place of y2, I'm going to write -2. In place of y1, I'm going to write 4. Now what happens? BC is going to be square root of 7 minus 6 is 1. The square, I need to write it as it is. -2 minus 4 is -6. Let me write the square as it is. Now what happens? BC is going to be, so 1 square is 1 itself, minus, if you square it, it becomes plus. 6 square is 36. So I'm getting BC as root 36 plus 1 is 37. So BC also I'm getting it as root 37. Let me also find out the side AC, which means I'm going to find out the distance between the point A and point C. Let me write point A, which is 5, -2, and then point C, which is 7, -2. Now this is our x1, y1, and this is our x2, y2. Let me write the distance formula. The distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. In place of x2, I need to write 7. In place of x1, I need to write 5. In place of y2, I need to write -2. And then in place of y1, I need to write -2. I have two negative signs very close to each other, so let me separate them by using a bracket here. Now what happens? This is going to be 7 minus 5, that gives us 2. And then this -2, let me write it as it is. Minus into minus, that gives plus 2 whole square. Now what happens? AC is going to be square root of 2 square is 4, but then this -2 and this +2, they cancel out and you end up getting 0 here. 0 square. 0 square is nothing but 0 itself, and then 4 plus 0 is nothing but 4 itself. Square root of 4 is 2. So the distance between the point A and point C is 2. The side AC is 2 units. Now from the triangle, I can see that two of the sides are equal. Two of the sides are equal. So I can say that the given vertices form an isosceles triangle. So you can conclude by saying AB is equal to BC. Since two of the sides are equal, you can say that the given points form an isosceles triangle. Let us now move on to the next question. Okay, so in question number 5, it says, in a classroom, 4 friends are seated at points A, B, C and D. This is point A, this is point B, this is point C, this is point D. So there are 4 friends who are seated at these 4 points. Champa and Chameli walk into the class, and after observing for few minutes, Champa asks the Chameli, don't you think ABCD is a square? So Champa feels that ABCD should be a square, which means if you join the points A, B, C and D, you should get a square. Let's try to join these points A, B, C and D. If we join them, Champa feels that we should end up getting a square. We should end up getting a square. But then Chameli disagrees. She has a different opinion. She thinks that no, when you join A, B, C and D, we will not get a square. Now what are we supposed to do? We are supposed to use the distance formula and find out who is correct. Let us find out who is correct by using the distance formula. So what are we going to do? We will find out what is AB, what is BC, what is CD, what is AD. If all the four sides are equal, and then if the diagonals are also equal, AC and BD are the diagonals. If all the 4 sides are equal and if the diagonals are equal to each other, then we can say that ABCD, it forms a square, isn't it? So let us find out AB, BC, CD, AD, all the sides of this, and then we'll find out the diagonals AC and BD as well. First things first, let us write the coordinates of point A. What are the coordinates of point A? If I go towards the x-axis, it says 3 here, and then if I go towards the y-axis, it says 4 here. So the coordinates of point A are 3, 4. What are the coordinates of point B? If I go towards the x-axis, it says 6, and then if I go towards the y-axis, it says 7. So the coordinates here are 6, 7. What are the coordinates of point C? If I go towards the x-axis, it says 9, and then if I go towards the y-axis, it says 4. So 9, 4. If I go towards the x-axis, it says 6. If I go towards the y-axis, it says 1. So 6, 1. So those are the coordinates of point of A, B, C and D. Let me first find out the distance AB. A is 3, 4 and then B is 6, 7. This is x1, y1 and this is x2, y2. Let us write the distance formula. The distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. Personally, I really do not write the distance formula when calculating the distance. I know that I need to subtract the x coordinates and then square them, plus subtract the y coordinates and then square them. So I usually subtract the smaller coordinate from the bigger coordinate. That's what I personally do. So from 6 I subtract 3, and then from 7 I subtract 4. From 7 I subtract 4. So this is something that I personally do. Anyways, if you substitute in the formula also, you mostly get the same thing itself. In place of x2 you're writing 6, in place of x1 you're writing 3, in place of y2 you're writing 7, in place of y1 you're writing 4. So what is AB going to be? 6 minus 3 is 3, the square as it is. 7 minus 4 is 3, the square as it is. 3 square is 9, 3 square is 9, 9 plus 9 is 18. Let me take prime factorization of 18. 2 into 9 is 18, 3 into 3 is 9, 3 into 1 is 3. So root 18 can be written as 2 into 3 into 3. 2 into 3 into 3. Now out of these two same numbers, I can take one number outside the square root, and inside the square root this 2 is remaining. So the distance between the point A and point B is 3 root 2. Let us also find out the distance between the points B and C. What is B given to us? 6, 7, and then what is C given to us? 9, 4. So BC is going to be square root of 9 minus 6 whole square plus 7 minus 4 whole square. This is what I personally do. I know that instead of writing x2 minus x1, I can write it as x1 minus x2 also, because when you square, you end up getting the same thing. So that's the reason this is what I personally do. I subtract the x coordinates from the bigger number. I always subtract the smaller number, and then I subtract the y coordinates from the bigger number. I subtract the smaller number. This is something that I personally do. 9 minus 6 is 3, square as it is. 7 minus 4 is 3, the square as it is. 3 square is 9, 3 square is 9, 9 plus 9 is 18, and again root 18 is nothing but 3 root 2. So BC also, we ended up getting BC as 3 root 2. Let me also find out CD. C is 9, 4, and then D is 6, 1. Let us find out CD. You can write it as CD, or you can just write it as DC, your personal choice. Now what would be the distance between C and D? Subtract the x coordinates. The x coordinate is 9 here, the x coordinate is 6 here. So 9 minus 6, square it, and then subtract the y coordinates. The y coordinate is 4 here, the y coordinate is 1 here. So 4 minus 1 whole square. CD is going to be 9 minus 6 is 3, 4 minus 1 is 3, 3 square is 9, 3 square is 9, 9 plus 9 is 18, and square root of 18 is nothing but 3 root 2 once again. So I ended up getting the distance between the point C and point D as 3 root 2 once again. Now let us find out the distance between point A and point D. Point A is given as 3, 4, point D is given as 6, 1. What would be the distance between point A and point D? Subtract the x coordinates. 6 minus 3, square it. Subtract the y coordinates. Always from the bigger number subtract the smaller number. This is what I personally do. I mean, at your level you can use the distance formula and substitute in the distance formula, but then I personally just subtract the x coordinates, square them, and then I subtract the y coordinates and then square them. From the bigger number I subtract the smaller number. Now what happens? 6 minus 3 is 3, square as it is. 4 minus 1 is 3, 3 square as it is. 3 square is 9, 3 square is 9, 9 plus 9 is 18, and square root of 18 is nothing but 3 root 2. So again, AD, the distance between point A and point D, I ended up getting it as 3 root 2. So we see that all the four sides are equal. Now we'll also find out the diagonals of this thing. Let us find out the diagonal here. AC is one of the diagonal, and then BD is the other diagonal. Let us find out AC and BD. A is 3, 4, C is 9, 4. What is AC going to be? Square root of 9 minus 3 whole square plus 4 minus 4 whole square. 9 minus 3 is 6, 6 square plus 4 minus 4 is 0, 0 square. So 0 square is nothing but 0 itself, so 6 square remains as it is. The square and the square root gets cancelled. You end up getting AC as 6. So I'm getting AC as 6, the diagonal AC as 6. In the same manner, let us find out the diagonal BD as well. Let us also find out the diagonal BD. Now let me find out the diagonal BD here. What is B given to us and what is D given to us? B is given as 6 comma 7, and then D is given as 6 comma 1. So what is BD going to be? Square root of 6 minus 6 whole square plus 7 minus 1 whole square. Now 6 minus 6 is 0, and then 7 minus 1 is 6, so we end up getting it as 0 square is 0 itself, so 6 square remains as it is. The square and the square root gets cancelled, and you end up getting BD as 6. So I ended up getting both the diagonals as 6 units, and then we see that all the four sides are equal. So we see that all the four sides AB, BC, CD and AD, all the four sides are equal, and the diagonals AC and BD, they are also equal. All the sides are equal, and then the diagonals are also equal. So you can say that the 4 points form a square. Let's move on to the next question now. Question number 6. Okay, now question number 6 says, name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. Now I have 4 points given to me, and then I want to find out what type of quadrilateral these 4 points form. Let us say this is our point A, this is point B, this is point C, this is point D. So we will, okay, let me just draw a rough quadrilateral here, A, B, C and D. So what am I going to do? I'm going to find the distance AB, which means I'm going to find the side AB, and then I'll find the side BC, find the side CD, find the side AD. If all the four sides are equal, then find the diagonals. If the length of the diagonals AC and BD are also equal, then you can say that this quadrilateral forms a square. If just the opposite sides are equal and the diagonals are not equal, you can say that it is a parallelogram, isn't it? So let's try to find out all the four sides first. Let us find out AB, and then BC, and then CD, and then AD or DA. Your personal choice. Now let's find the distance between A and B. A is given as minus 1 comma 2, and then point B is 1 comma 0. So AB is going to be square root of, you can write the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. Let's write it, x2 minus x1 whole square plus y2 minus y1 whole square. This is x1 y1 and this is x2 y2. So AB is going to be square root of, in place of x2 I'm going to write 1, in place of x1 I'm going to write minus 1, in place of y2 I'm going to write 0, in place of y1 I'm going to write minus 2. Since this minus and this minus, they are very close to each other, let me separate them by using a bracket. Same here, this minus and this minus, they are very close to each other, let me separate them out by using a bracket. So what do I end up getting now? Square root of, this is 1 here, and then 1 minus into minus, that gives me plus 1 whole square, and then 0 minus into minus, that gives me plus 2 whole square as it is. So AB is going to be square root of 1 plus 1 is 2 square as it is, 0 plus 2 is 2 square as it is, 2 square is 4, and then 2 square is 4, 4 plus 4 is 8. Let us take prime factorization of 8. 2 into 4 is 8, 2 into 2 is 4, 2 into 1 is 2. So 8 can be written as 2 into 2 into 2, isn't it? Now out of these two same numbers, you can take one number outside the square root, and inside the square root just this 2 is remaining. So I got AB as 2 root 2. In the same manner, let us find out the side BC. Let me first write the point B and point C. Point B is 1 comma 0, and then point C is minus 1 comma 2. So what is BC going to be? Let us write the formula and substitute in the formula. x2 minus x1 whole square plus y2 minus y1 whole square. x2 is, this is x1 y1 and this is x2 y2. In place of x2 let me write minus 1, in place of x1 let me write 1, in place of y2 let me write 2, in place of y1 let me write 0. Now what happens? BC is going to be square root of minus 1 is minus 2 square as it is. 2 minus 0 is nothing but 2 itself, the square as it is. Minus 2 square is plus 4, 2 square is 4, 4 plus 4 is 8, and then root 8 is nothing but 2 root 2. So again BC also I got it as 2 root 2. In the same manner, let us find out the side CD. C is minus 1 comma 2, and then D is minus 3 comma 0. So this is your x1 y1, this is your x2 y2. Let us find out CD. CD is going to be again square root of x2 minus x1 whole square plus y2 minus y1 whole square. What is x2 here? In place of x2, let me write minus 3, and then this minus sign I'm writing as it is from the formula. In place of x1, let me write minus 1, the square as it is, and then in place of y2 I need to write 0, and then this minus sign I'm writing it from the formula. Y1 is 2. Okay, so now what do I end up getting? CD is equal to square root of, now this minus sign and then this minus sign, they are very close to each other. Let me separate them by using a bracket here. Now what happens? Minus 3 minus into minus is plus 1 whole square, and then 0 minus 2 is nothing but minus 2 itself, minus 2 square. Now minus 3 plus 1 is minus 2 square as it is, and then this minus 2 square let me write as it is for now. Now what happens? CD is going to be minus, if you square it, it becomes plus, isn't it? 2 square is 2 into 2, 4. Minus, when you square it, it becomes plus. 2 square is 4. 4 plus 4 is 8. Square root of 8 is nothing but 2 root 2. So again CD also we ended up getting it as 2 root 2. In the same manner, you can find out AB as well. A is minus 1 comma minus 2, D is minus 3 comma 0. So let's find out the distance between the point A and point D. That is going to be minus 3 minus of minus 1 is plus 1, 0 minus of minus is plus 2. So this is going to be minus 2 square plus 2 square, which is again going to be root 8, which means AD is again 2 root 2. Okay, so AD we got it as root 8, and then root 8 is nothing but 2 root 2. So AD again we got it as 2 root 2. So AD is also 2 root 2. So we see that all the four sides are same. Now let us also find the diagonals. We'll find out the length of the diagonal AC, and then we'll find out the length of the diagonal BD. So let us use the distance formula to find out the distance between point A and point C. That gives you the length of the diagonal AC. So what is A and what is C here? A is minus 1 comma minus 2, and then C is minus 1 comma 2. So this is again your x1 y1, and this is your x2 y2. So AC is going to be square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so AC is going to be minus 1 plus 1, they cancel out and you end up getting a 0 here. So this is 0 square, and then 2 plus 2 is 4, 4 square. So AC is going to be 0 square is 0 itself, 4 square is 16, 0 plus 16 is 16, square root of 16 is 4. So we got AC as 4. We got AC as 4. We got AC as 4. In the same manner, we'll find out the length of the other diagonal BD. What is B and what is D here? B is 1 comma 0, and then D is minus 3 comma 0. So BD is going to be square root of 1 minus of minus 3 is plus 3, 0 minus 0 whole square. I did a direct substitution here, but then you can write the formula and then you can substitute in the formula. Square root of 1 plus 3 is 4, so this is 4 square. 0 minus 0 is 0, 0 square is nothing but 0 itself, so I end up getting 4 square. 4 square is nothing but 4. So we see that all the four sides are equal and the length of the diagonals are also equal. So the given 4 points form a square. The given 4 points form a square. Now in the same manner, we have 2 more bits in the 6th question. I will write those 2 bits, and I want you all to try those 2 bits by yourself. You have to do the same thing again. Find out all the four sides and find out the length of the diagonals and then decide what kind of quadrilateral it is going to be. Okay, so now the question number 7 says, find the point on the x-axis which is equidistant from 2, minus 5 and minus 2, 9. Let us consider this point as A and then let us consider this point as B. So we have to find a point on the x-axis. A point on the x-axis will be of the form x, 0 because on the x-axis the y coordinate is 0, isn't it? So let us say we have a point P whose coordinates are x, 0 and this point is equidistant from the given 2 points. What are the 2 points that are given to us? 2, minus 5 and then minus 2, 9. Equidistant means equal distance. So the point P, which is on the x-axis, is at an equal distance from the given 2 points, meaning the distance of point P from A, which is PA, is equal to the distance of point P from B, which is PB. Let us find out PA and PB. How do you find out PA? PA is the distance from the point P to the point A. Let us use the distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. For now, I'm just going to subtract the x coordinates, square them, subtract the y coordinates and square them, because that is what you personally ideally do in a distance formula, right? Let us use the distance formula here as well to find out PB. X minus of minus 2 is plus 2 and then 9 minus 0 whole square. Now let us expand this by using a minus b whole square formula, which is a square minus 2ab plus b square. Now 0 plus 5 is 5 square as it is. Now let us expand this by using a plus b whole square formula, which is a square plus 2ab plus b square. Now 9 minus 0 is 9. So 9 square, let me write it as it is for now. What happens now? X square minus 2 into 2 is 4, 4 into x is 4x, 2 square is 4, 5 square is 5 into 5, which is 25. Now here what do I get? X square plus 2 into 2 is 4, 4 into x is 4x, 2 square is 4, 9 square is 81. Now I can add these two numbers, so let us add those two numbers. 25 plus 4, that gives us 29. I can add these two numbers, so let me add those numbers. 81 plus 4, that gives us 85. To get rid of the square root, let us square on both sides. So the left hand side, that's the left hand side. I'm going to square the left hand side to get rid of the square root, and I'm going to square the right hand side as well. That's the right hand side. We are going to square the right hand side as well. Now what happens? The square and the square root, they cancel out. The square and the square root, they cancel out. And what are we left with? X square minus 4x plus 29 is equal to x square plus 4x plus 85. Now there is one other thing that you can do. Instead of finding PA and PB, you could have squared here itself and then you could have found out PA square and PB square instead. PA square will not have the square root in it because PA is square root of this thing. PA square would have been this thing without the square root. So you could have got rid of the square root here itself by equating PA square and PB square instead of equating PA and PB. But then that's a personal choice that you have. Now what we'll do is we'll transpose the left hand side completely to the right hand side. So what happens? The right hand side, let me write it as it is for now. Plus x square, if I transpose it to the right hand side, it becomes minus x square, minus 4x, that becomes plus 4x, plus 29, that becomes minus 29. So nothing is left on the left hand side, so you'll write a 0 on the left hand side. Instead of writing 0 is equal to this, you could have very well written this is equal to 0. That is something that you can try. Now plus x square and minus x square, they will cancel out. 4x plus 4x, that gives me 8x. 85 minus 29, 85 minus 29, 15 minus 9 is 6, 7 minus 2 is 5, so 85 minus 29 is 56. Now let us solve this simple equation. Plus 56, if you take it to the right hand side, it becomes minus 56. So 8x is equal to plus 56. If I transpose it to the right hand side, it becomes minus 56. X is going to be minus 56 by 8. 8 into 7 is 56. So x value I'm getting it as minus 7. Previously we considered that x comma 0 is a point on the x-axis. Now in place of x I'm going to substitute minus 7. So minus 7 in place of x I wrote minus 7. Minus 7 comma 0 is the required point on the x-axis. So this is the point on the x-axis which is equidistant from the given 2 points. Let us move on to the next question now. Now the question number 8, it says find the values of y for which the distance between the 2 points is 10 units. So it is given the distance between point P and point Q. The distance between the point P and point Q, which is PQ, is equal to 10 units. Now, what is PQ? PQ is the distance between P and Q. And what is the distance formula? It is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So PQ is going to be square root of x2 minus x1 whole square plus y2 minus y1 whole square. If you want to get rid of the square root in the initial stages itself, you can square on both sides. When you square on both sides, what do you end up getting? PQ square is equal to 10 square, which is 10 square is 10 into 10, 100. Now I'll write the distance formula without the square root because I have squared it already. So let us use the distance formula here, which is x2 minus x1 whole square plus y2 minus y1 whole square. I'm not writing a square root because I'm not finding PQ, I'm finding PQ square. So the square root, we got rid of the square root in the initial stages itself. I did not write the distance formula here. You can write the distance formula and then you can do the substitution, but then I am doing it in a pretty direct manner here. I subtracted the x coordinates and then I squared them, plus I subtracted the y coordinates and then I squared them. 10 minus 2 is 8 square plus, this is something that we can expand using a plus b whole square formula, which is a square plus 2ab plus b square. Now what happens? 8 square is 64. This is y square. 2 into 3 is 6. 6 into y is 6y. 3 square is 3 into 3, which is 9. So what do we end up getting now? We end up getting y square plus 6y plus 64 plus 9 is how much? 64 plus 10 is 74. So it should be 73 is equal to 100. So y square plus 6y plus 73 minus 100 is equal to 0. Plus 100, if you transpose it to the left hand side, it becomes minus 100, isn't it? Now, y square plus 6y 73 minus 100, that gives us 27. The bigger number is 100. It has a minus sign, so let me write minus 27 here. Now we can do we can split the middle term by we can factorize this quadratic equation by splitting the middle term. How do you split the middle term? 1 into 27 is 27. 9 into 3 is 27. 9 minus 3 is 6. So 6y can be written as 9y minus 3y. There are two ways of finding the roots of a quadratic equation. You can either split the middle term to factorize this, or else you can use the quadratic formula. This is something that you must have already learned in quadratic equations chapter, right? Now, so I'm splitting the middle term. 6y can be written as 9y minus 3y. And then from the first two terms I can take y common. From the next two terms I can take minus 3 common. Now this is the first term and then this is the second term. From these two terms I see that I can take y plus 9 common, because y plus 9 is there in both the terms. So if I take y plus 9 common, from the first term I'm left with y. If I remove y plus 9 from the second term, I'm left with minus 3 here. Now since the product of these two is equal to 0, the first one has to be 0 or the second one has to be 0, because only when you multiply something by 0 you end up getting the product as 0, isn't it? Now plus 9, if you take it to the right hand side, it becomes minus 9, and then minus 3, if you take it to the right hand side, it becomes plus 3. So what are the values of y? The values of y are 3 and minus 9. Let us now move on to the next question. Now question number 9 says if q 0, 1 is equidistant from p 5, minus 3 and r x, 6 find the distances. Okay, I must not have written the complete question. Usko pause karo. Okay, so now the question number 9 says, if q 0, 1 is equidistant from p 5, -3 and r x, 8, find the values of x. Also, find the distances QR and PR. So let us try to understand the question first. It says the point Q, which has the coordinates 0, 1, this point is at an equal distance from the other 2 points. So this point Q is at an equal distance from point P and from point R. The point P is given as 5, -3. The point R is given as x, 6. So point Q, which is 0, 1, is equidistant, meaning it is at an equal distance from these 2 points, which means the distance of the point Q from R is equal to the distance of the point Q from P, which means QR should be equal to QP, isn't it? QR, the distance of the point Q from the point R, is equal to QP, which is the distance of the point Q from the point P. Now, you can actually, instead of finding QR is equal to QP, you can square on both sides initially itself, because if you find out QR, you're going to get a square root. QR, the distance between Q and R, you'll get a square root, because the distance formula has a square root. If you want to get rid of the square root in the initial stages itself, you can just square on both sides. Now you are going to use the distance formula without the square root, because you have already squared this. Let us find out what is QR square, and then let us find out what is QP square. I'm going to do it on another page here. So what do we have to do? QR square, which is x minus 0 whole square plus 6 minus 1 whole square. X minus 0 whole square plus 6 minus 1 whole square. I'm just making use of the distance formula itself. I'm subtracting the x coordinates and then squaring them, plus I'm subtracting the y coordinates and then squaring them. Let us do the same thing here also. 5 minus 0 whole square plus minus 3 minus 1 whole square. Minus 3 minus 1 whole square. So what do I end up getting? X minus 0 is nothing but x itself. So x square plus 6 minus 1 is 5. 5 square is equal to 5 minus 0 is nothing but 5. And then minus 3 minus 1 is nothing but minus 4. So what do I end up getting? X square plus 5 square is 25. 5 square is 25. Minus, when you square it, it becomes plus. 4 square is 16. So x square plus 25 is equal to 41. Or else you could have done like this also. Plus 25, if you transpose it to the right hand side, becomes minus 25, and then eventually this plus 25 and this minus 25, they cancel out, and then you will be left with only x square is equal to 16. So you can do it that way as well. Or else you could have done it like this also. 41 minus 25, that gives you 16. X is going to be square root of 16, which is plus 4 and minus 4. Square root of 16 is plus 4 also and minus 4 also. Why? Because 4 square is 16. So that's the reason square root of 16 is 4. Minus 4 square, minus 4 whole square is also 16. So square root of 16 is also minus 4. So we got two values for x here. We got two values for x, and that's the reason he is asking you to find the values of x. We found out the values of x. Now what are we supposed to find out? We are supposed to find out the distance QR and the distance PR. Let us find out the distance QR. What is Q here? Q is 0, 1, and then what is R here? R is x, 6. But then R is x, 6. In place of x, I'm going to write plus 4 ones, and then in place of R, you can write minus 4 the next time. Okay. Q is 0, 1. In place of x, I'm going to write minus 4 the next time. R is x, 6, but x is plus 4 or minus 4. The first time let us write 4 here, plus 4, and then the next time let us write minus 4. Let us find out the distance QR, because that is what it says. Find the distance QR. Let us find out the distance QR. The distance QR is going to be square root of x2 minus x1 whole square plus y2 minus y1 whole square, which is 4 minus 0 is 4, square as it is, 6 minus 1 is 5, 5 square. So QR is going to be 4 square is 16, 5 square is 25. So QR is going to be 25, 30, 40, 41, right? 16 plus 25 is 41. So QR is square root of 41. Now let us find out the distance QR when the x coordinate, when the value of x is minus 4. So what is QR going to be here? In this case, it is going to be 0 minus of minus 4 is plus 4, 6 minus 1 whole square. QR is going to be 0 plus 4 is 4, 6 minus 1 is 5. QR is going to be 4 square 16, 5 square 25. So QR is going to be root 41 once again. So the distance between the point Q and the point R is root 41. Let us find out the distance PR. Let us find out the distance PR. Point P is 5 comma minus 3, and then what is point R? Point R is x comma 6. In place of x, let me write 4 here. You can write plus 4 first, and then the next time you can do it again by writing minus 4. So PR is going to be square root of 5 minus 4 whole square plus 6 minus of minus 3 is plus 3 whole square. I'm doing it a little directly here. I'm subtracting the x coordinates and then squaring them, plus I'm subtracting the y coordinates and squaring them. You can use the distance formula, write the distance formula, and then substitute the values and do it. But then I'm sure by now you must have understood what the distance formula is, and from if you pay a close attention to the formula, you will see that you just need to subtract the x coordinates, square them, plus subtract the y coordinates and then square it. 5 minus 4 is 1, 6 plus 3 is 9. So what do I end up getting? PR I end up getting as 1 plus 81, which is root 82. In the same way, the next time, in place of x, you can write minus 4 here. So P is 5 comma minus 3, but then R is minus 4 comma 6. Let us see if that makes any change here. Let's see if that makes any change here. PR is going to be square root of 5 minus of minus 4 is plus 4, 6 minus of minus 3 is plus 3. So PR is going to be 9 square plus 6 plus 3 is 9, 9 square. So PR is going to be 81 plus 81, which is 162. And 162, you can take prime factorization of 162. 2 into 8 is 16, 2 into 1 is 2. 3 into 27 is 81, 3 into 9 is 27, 3 into 3 is 9, 3 into 1 is 3. So PR can be written as square root of 2 into 3 multiplied 4 times, right? 2 into 3 into 3 into 3 into 3. Out of these two same numbers, you can take one number outside the square root. Out of these two same numbers, you can take one number outside the square root. Inside the square root, you just have 2 remaining. 3 into 3 is 9, so you end up getting PR as 9 root 2. Question number 10 says, find a relation between x and y such that the point x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. So we have a point here, x comma y. There's a point x comma y which is at an equal distance from these 2 points, 3 comma 6 and minus 3 comma 4. Let us give this a name. Let us say this is point P, this is point A, and this is point P. So the distance of point P from A is equal to the distance of point P from B, which means PA is equal to PB. PA is equal to PB. Now if you want to get rid of the square root in the initial stages itself, you can square this on both sides. So you end up getting PA square is equal to PB square. And what is PA square going to be? You have to subtract the x coordinates, square it, and then keep the plus sign, subtract the y coordinates and square it, or just use the distance formula. I am just going to subtract the x coordinates. Remember, the first coordinate is the x coordinate. So x minus 3 whole square, x minus 3 whole square plus y minus 6 whole square. That should be equal to pb square. X minus of minus 3 is plus 3. So x plus 3 whole square plus y minus 4 whole square. Now what happens? Let us expand this by using a minus b whole square formula, which is nothing but a square minus 2ab plus b square. Let us expand this also by using a minus b whole square formula, which is a square minus 2ab plus b square. Let us expand this also by using a plus b whole square formula, which is a square plus 2ab plus b square. Let us expand this also by using a minus b whole square formula, which is a square minus 2ab plus b square. Now what happens? X square minus 2 into 3 is 6, 6x, 3 square is 9, y square 2 into 6 is 12, 12y, 6 square is 36, and right hand side what do I end up getting? X square plus 2 into 3 is 6, 6x, 3 square is 9, y square minus 2 into 4 is 8, 8 into y is 8y, and then 4 square is nothing but 16. Now, let us simplify the left hand side first, and then we'll simplify the right hand side, and then we'll see what we can do here. X square minus 6x plus y square minus 12y. These two numbers we can add them up, right? 36 plus 10 would have been 46, but since we are adding one less, we'll get one less than 46, so we get 45. 36 plus 9 is 45. And now what I am getting here? X square plus 6x plus y square minus 8y. 16 plus 9 is 25. 16 plus 10 is 26. So this becomes 25. Now let us transpose all of this to the right hand side. So left hand side, nothing would remain, so you get a 0 here. I'm transposing the entire left hand side to the right hand side. Let me first write what is given on the right hand side. X square plus 6x plus y square minus 8y plus 25 plus x square. If I transpose it to the right hand side, it becomes minus x square, minus 6x will become plus 6x, plus y square becomes minus y square, minus 12y, that becomes plus 12y, plus 45, that becomes minus 45. So what do we end up getting? This plus x square and this minus x square, they cancel out, and then this plus y square, this minus y square, they cancel out. 6x plus 6x, that gives us 12x, minus 8y plus 12y. 12 minus 8, that gives us 4, right? So 12y minus 8y is 4y. 25 minus 45, that gives us minus 20. Now instead of writing 0 is equal to this thing, you could have written this as equal to 0. So you could have written this thing is equal to 0. Now you see that you can throughout cancel this by 4 table, because 12, 4 and 20, they all go by 4 table. So let us cancel them by 4 table. 4 into 3 is 12, 4 into 1 is 4, 4 into 5 is 20. So we end up getting 3x plus 1y minus 5 is equal to 0 as the relation here. Glad you made it to the very end of the video. In the next video, I will derive a formula to find out the coordinates of a point which is cutting the line segment joining 2 points in a certain ratio. And this formula that I'm going to derive in the next video is known as section formula. We'll also talk about a special case of section formula, which is midpoint formula, and then we will finally also complete the second exercise in the next video. I look forward to see you all in the next video. Have a great day ahead. Goodbye.